Hello, everyone. Let me check if you're all right, and then we can get started. Okay, I think we're all good. So let me put up my slides, and then we'll do a short talk, and then after that, we'll progress with the rest of the program. All right. Let's go back. Let me double check if everything is showing up correctly, and then we'll get started. Okay, I think everything is all good. So let's do it. So a very warm welcome to everyone who's joining in, tuning, and watching it from Twitter. This is the first hackathon that we're doing in collaboration with EigenLayer. So AllClair and EigenLayer is doing this together. And as the title says, it's a hackathon to build AVSs. So for those who are not very familiar with AllClair, let me give you a quick intro to who we are and what we do. So we started off as a RaaS service with the goal that we would make it easier for people to deploy their own rollups. So imagine if you had OP Stack, Arbitrum Orbit, Polygon CDK, and there's some of the other stacks that are out there. If you wanted to have a chain dedicated for your own purpose and app-specific use case, they would help you do that. So you would help you run all the backend infrastructure, backend sequencers, and everything. We offer that service to you. So that's something that we have been doing for quite a while now. And over the last year or so, I would say, we started looking quite deeply into the EigenLayer ecosystem and the restaking ecosystem. And we came up with this new idea that we call restake rollups, which is essentially a framework that brings restaking and EigenLayer's restaking mechanism to rollups. And it gives rollups different benefits. So for example, you could imagine building a fast finality layer as an AVS that will help support your rollup. So as you know, rollups are not great in terms of, so when you use a rollup, you have the sequencer that gives you some sort of confirmation, and that may not be ideal because you may want something which is much more concrete or something that can be considered harder in terms of finality. And that's something that this new AVS that we call Mark can offer you through economic backing that EigenLayer provides. So we have been doing and building this restaking framework and restaking rollup framework for quite a while. And through that, we have been engaged with all sorts of operators. We have ourselves built 5 AVSs that are currently live on EigenLayer's mainnet. And through that experience of building, managing, and coordinating all the broader ecosystem and operators that you need to have an AVS live and running, we felt like there's a need to build something interesting that could help people deploy AVS faster and in a much better way. So that's a product that I'm going to present, and me and my team are going to present that in a while. But the idea is for you to use that and hopefully benefit from that product that we're going to announce today and use that in the AVS hackathon today. So a quick reminder for those who are new. So registration opened on 2nd of October. It will continue and will be open throughout the hackathon. So until 31st of October this year. And then towards the end, so on November 5th, we'll have winners announced. And the top 3 winners of this program will be invited to come and present and speak at our flagship event that's going to happen along the sidelines of DevCon on November 13th in Bangkok. So for those who have never been to our event, these are really big events, and I would encourage you to strive for the best and come in the top 3. Because you will have an opportunity to present in front of some of the biggest builders in the space, including, for example, in the last event and some of the events that we have done in the past, we had people like Vitalik Buterin, Sriram, and some of the top builders in the space who came and spoke either as a speaker or as a panelist. So if you come at the top, you will have that opportunity to share the same platform with the likes of Vitalik and others to share what you have built during this hackathon. So I guess it's the cherry on the top in some sense, other than the prize money that comes with it, right? So we have about 100K in rewards, again, partly offered by EigenLabs, which they were very generous to offer this reward to hackathon participants, and then part of that is offered through AllClayer, all tokens, and there's some bounties as well that I'm going to announce in a minute. So anyone that is involved in the hackathon has an opportunity to win if you're in top 100. And top, the winner of this hackathon will, I haven't run the numbers, but I think it should be about 20K USD worth of reward that you can earn, alongside the speaking opportunity that you will have at DEF CON, roll-up day at DEF CON. So yeah, we have 3 big partners who are offering their own bounty tracks. So one is Automata, which have been heavily involved in building TE SDKs. So SDKs that you can use to build TE style applications, so trusted execution environment applications. Brevis, which is ZK coprocessor, and also Lagrange, which has a similar offering. They will also do their own presentations towards the end. But at a high level, what I'm saying is that there are separate bounty tracks for people who want to use some of the products and services that are being built by these partners. In terms of some of the useful links, so we have 2 main links. One is on the left, that's the Hacker's Guide. So this guide contains all the information that you need to know how the hackathon will work, the rules of the game. And also you'd see a table towards the end, which I've not presented here, but there's a table at the end that tells you some of the things that are going to happen over the next week or so. So for example, we'll have some of these speakers coming in to explain to you what things that they're building, how you can benefit and get mentorship from them. And we'll also have some office hours with EigenLayer and AVSthon. You can ask them and ask questions around AVSs, around some of the toolings that we provide ourselves, but also more generally what you're building. If you want to brainstorm ideas that you're thinking of building, come and join, come and talk to us during those office hours. So yeah, go to Hacker's Guide if you want all the info regarding this hackathon and how this play out. On the right, you'd see a DevFolio registration, which is I guess a popular platform for hackers and hackathon organizers. So we have used DevFolio this time to help you, for example, register first of all, if you haven't yet. And 2, once you have registered, you can actually go and submit your project and submissions, and then you will have judges who will come and judge the submissions that you made. So DevFolio would be your go-to platform for anything around hackathon, and the Hacker's Guide is, I guess, a tutorial material that you need to know all the rules and the dates and anything that you may need for the rest of the hackathon. Now let me explain to you very briefly a tool that we have been building. Again, as I said, we have been building in the Eigen space for quite a while, and we have accumulated a bit of experience in doing so. And this tool, the goal of this tool is basically, when we built this tool, our idea was that to take that experience in and provide the right tools for people so that their development could be much easier, much faster, much more streamlined. And so this was basically an accumulation of the experience that we have earned over the last year or so. And hopefully you will like the tool that we have built. So you can go and try this tool at wizard.altair.io. It's available. You can go and play with it, and hopefully you will use it during the course of the hackathon. Now let me tell you what exactly it does. But before that, for those who are new to AVSs, so actively evaluated services, it's essentially like a middleware that you could build. It could be a network, it could be a POS chain, anything that you can imagine. It's a network, it's a service that you could use, that you could build using EigenLayer's restaking mechanism. And AVS basically has 2 components. The first part, which is on the left, it's the on-chain component. So these are smart contracts that need to be deployed on-chain for the AVS to be operational. So you could imagine, for example, if you are borrowing staked assets from Ethereum, or you want your own token to be used for economic collateral, economic staking, then there are a bunch of contracts that handle that. There are a bunch of contracts on this on-chain component that handles, for example, operator registration. So if you want to bring an operator, that operator has to be registered in one of those contracts, and this on-chain component handles that. There's an on-chain component that handles, for example, submissions. So you could imagine, when this service, let's say you're building an Oracle Chainlink like Oracle service, the Oracle service has to input something back to on-chain, and this chain, for example, this service can go and verify whether your output is actually valid. In the coming weeks and months, you'll also have, for example, on-chain contracts that will handle reward mechanism. So how would you reward your operators and stakers who are securing your AVS? You could also imagine a slashing mechanism, so a mechanism that would slash if an operator does something malicious. So all these contracts need to be deployed and, of course, tailored depending on the AVS that you have, and they have to be deployed on-chain. So this is the on-chain component. On the right is your off-chain component. So these are components that you need to run alongside the on-chain component for the entire AVS to actually work. So a very simple way to think about it is like, now that you have the on-chain component, you have some of the operators, you have to find something, you have to give something to the operators to actually run. So this is what it's called the client code. So the operator will need to run some client code that actually does the actual task that the operators are supposed to do. And then those operators then will submit their output, and that eventually would go on chain. So the off-chain component, you have to basically deploy and build and develop a client code that the operators will have to run. And then you have to organize and coordinate a bunch of operators who will then run that client code for your service. So, and all of this is actually, and if you think about it, it's actually a time-consuming process, because you have to deploy a bunch of contracts, build a bunch of on-chain contracts in Solidity, but also develop client code. You also have to develop and basically do at the social layer this coordination thing, which requires you, for example, talking to operators, bringing those operators in, and getting them whitelisted and so on. So it's a very time-consuming process, and our goal with Wizard is to simplify that. So Wizard basically is at a very high level. Wizard is a tool which we call an AVS-as-a-Service platform. It's a tool that helps you deploy and manage AVSs. And in short, it's an AVS-as-a-Service platform. So more concretely, what it does is it allows you to deploy and manage the different components that are needed for this operator, for this AVS to actually become operational. So all the on-chain components, or most of the on-chain components, will be handled by us by Wizard. And the off-chain component involves, as I said, writing the underlying node client, and then also handling the operator management. So a lot of operator management, as I said, could be painful, could be time consuming, because you may not know how to reach out to operators, and so that all of that gets handled through Wizard through our site. So all you have to do is, for example, click and choose the operators that you actually want, and then behind the scenes, the Wizard and the rest of the operator team will actually do the work to actually onboard those operators for you. There's also a very cool feature. We will also offer a managed service, but I'm going to get to it in a minute. So in more concretely, so these are some of the things that we actually offer through this Wizard. So the first part, as I said, is the creating of the AVS. And in this mode, we offer a very interesting feature that we call the template services. So there are a bunch of contracts that we feel could potentially be useful in a certain templatized way. So imagine, for example, you're building a game and you want to have a certain kind of Oracle service deployed. And so we have actually created an entire template of set of contracts that would help you deploy that specific Oracle service right off the gate. So you don't have to make any modification. You could use basically that. But of course, it's also open-ended. So for example, if you want to build your own fancy, I don't know, ML or AI style AVSs, you could actually go and build your own custom contracts through the platform that we provide. So you could build your contracts or use our existing contracts, modify them, or bring your own contract that's completely written from scratch, and you can use that and deploy them through our platform, with clicks. The creation part also involves, for example, which strategy you want to choose. So for example, do you use, let's say, ETH strategies, or do you use some of the other strategies that EigenLayer provides? So you can pick and choose the strategies that you want for your AVS to support. So these are strategies that basically, at a high level, basically these are tokens that you want to use to secure your AVS. And overall, it helps you deploy and manage the different roles that you could imagine you would have in the AVS. So for example, if you want to change certain roles that the AVS has and you replace them with a certain different addresses that you may have, you could do that through the managed component that we offer through AVS. AVS has something called metadata, which basically describes what this AVS does, and different Twitter links and different descriptions that you could change. And the platform allows you for a seamless way to actually do that quite easily and quite quickly. You have ways to, for example, change different things around quorum strategies, change your service management contracts, and so on. So all of this can be, it's not just that once you deploy the contracts and once you deploy your AVS, it's all done. You have a progressive way and a way in which you can actually update some of the things that we offer through this management component of Wizard. Finally, as I said earlier, so there's an operator component where you can actually go and whitelist and pick and choose the operators that you actually want to solve your AVSs. You can actually eject them if you don't want them. And as I said last time, we also have a service that we call the hosted operator. So let's say, for example, you are building during this hackathon. By the way, you will have access to that, where if you don't want to onboard let's say 10, 20 operators because you might feel like it's time consuming, you could actually use and leverage all claim managed operator as well. So all you have to do is you have to select and say, hey, I want to have an all claim managed operator. And then we will furnish and provide you an operator that will be managed by us and would help and run the AVS that you have. So yeah, it's very broad in that sense, where it allows you to create and deploy some of the initial things that you need for the AVS to go up and running. And you would have an AVS management component that helps you manage AVS once it's actually deployed and running. And the third part is the operator management. That's something that's very time consuming, especially if you're coordinating and finding the operators to help you run. At this point, I'll pass over to my colleague Hanwen, who will give you a quick demo to explain to you how all these features come alive once you use something like Visit, and how you can actually go and deploy a functioning AVS on testnet within a matter of minutes, as opposed to if you're going to try all of this yourself, it will take you at least a month, if not more. So over to you, Hanwen.
Thanks a lot, Amrit. All right, so I'll just do a quick demo of how the wizard works. I'm a product manager here at AVSlayer, and it's my job to make sure that wizard works for all, and also get feedback from everyone in the community around what features we need to implement and change next. So to get to the dashboard, you just go to wizard.automata.network, and immediately you'll be greeted with a login screen, and just click login. You can log in with your Google account. So once you're logged in, you'll be able to view your current deployments for the AVS and also create new AVSs. So today I'm going to show you how to create Hello World AVS using our dashboard for EigenLayer. Once I click on new AVS, I give it a name, say AVSthon demo, and I'll choose the Hello World AVS-as-a-Service Manager template. You just explain quickly on all the templates. There are two types of templates. One is called AVS-as-a-Service Manager templates, and one is called BLS Service Manager template. AVS-as-a means that you are doing aggregation of the signature on-chain, and then for BLS, you are doing off-chain aggregation, and then you just submit it through the aggregator on-chain. So for here, we are going to do a demo for the deployment of Hello World, which is the AVS-as-a-Service Manager template. Additionally, we have other templates as well, such as AVSlayer Muck, which is our current proprietary fast finality layer for all the rollups. And we have Bridge, which is a generic bridge that we have created as a template, coprocessor, and so on. But you can also at the same time deploy custom service manager as well. So if you have a flattened contract, you can just paste the entire service manager flattened contract here, and then you can compile it and input your custom arguments, and you will be able to deploy it. So let's go back to Hello World. Once we choose that, we choose the supported restick strategy. Here we choose ETH-LST, which is by default. The threshold weight is 0 to 100, so just put it at 100 for this demo. Check the summary panel to see whether everything is correct and click on submit. And you will be prompted to connect your wallet. And here I connected my MetaMask wallet. So once you're done with that, you click on create, and you can confirm transaction on your MetaMask. So this is all happening on Holisky testnet. And if you have no Holisky testnet ETH, you can go to the faucet, Holisky testnet faucet, in order to get it. So the transaction now is confirmed, and I've created my AVS successfully. So if you have done so, you can go to this manage page for your AVS. Here you will be able to see what you have keyed in earlier, like AVS demo is the name of the AVS, the type is Hello World, and here you'll be greeted with other things as well. The user guide is here, so you can click on it in order to view it on your own time. But just let me quickly explain as well. So supported strategies here, you have ETH-LST. For ECDSA, you won't be able to use Eigen and Reord, but for BLS Service Manager, you can use all three different types of strategy. And on the operator side, you'll be able to whitelist your operator, as what Amrit has mentioned earlier, using our current UI. So let me just do a quick demo. If you want to whitelist new operators to this AVS, you can just click on here. Let's choose Hashkey Cloud, Nethermind, OKX, for example. And you save changes. You're prompted to update your whitelist. And similarly, just confirm transaction on MetaMask and wait for it to be included in the blockchain. And you'll be whitelisting all the 3 operators you've chosen. And you have to work with them off-chain afterwards to make sure that they register their operator to EigenLayer. And once they are done with that, they have the node software, which is the Docker image. They will be able to run it. We are currently still in the midst of actually developing the entire communication process for you to do registration, for you to communicate with your operators, do registration with EigenLayer, and also to make sure that you can run the node software. But once those are done, you can actually do it on the dashboard as well. But for now, it's still quite a manual process that we are still improving. For other things they can do at this manage page is to view the AVS details. So here you have the info page, which will lead you to the EigenLayer UI to check out the AVS you've just deployed. So here's the one. It doesn't have any information. That's the reason. The reason is because we have not actually input the AVS profile. So this is the AVS profile here. If you key in the AVS, the details as dictated earlier, in a JSON format, you'll be able to update the profile. And once you update it, it will just be reflected here as well. Other things you can do here is to view the contract addresses that you have deployed and check out the contract rows, and also at the same time edit the contract rows. So here, these are all basically my MetaMask account that I've used to deploy the contract, but I can change it to something else if I want to. The last thing is actually upgrade service manager. So this here is actually the implementation contract for the service management part. So if you want to upgrade it, this is actually catered to you because it's operating behind proxy. So anytime you want to upgrade your logic in your service manager implementation, you can just key in a contract address here and you can upgrade it on chain as well. Just quickly let you go through another creation just to make sure that you can take a look at the BLS side as well. So AVSthon, just quickly do so. BLS, you can choose all the 3 different types of strategy for the BLS service type. Deploy the contracts. There's a bit of difference here because you need to deploy the base contracts for BLS side and then deploy the service manager, as opposed to for the ECDSA side, you only need to deploy the service manager itself. So there are 2 transactions in total. Wait for the first transaction to be done. And we'll do the second one. And here we go. So this is how quick you can actually iterate on a wizard itself. Just for the last 5 minutes, I've deployed 2 AVS on the Holisky testnet, and that's the beauty of using this dashboard. So once the transaction is done, I'll be able to view and manage that AVS as well, which is here, right? So this is the BLS generic type AVS, which I have just deployed. Similarly, I can add new operators, but here you can see something different, which is the hosted operator service, which is hosted by the AVS team. So you don't actually need to have external third-party operator if you are still new to this development phase. So you don't have to communicate with someone else in order to actually run your AVS software. So we will run it for you. That's in this case. So if let's say we were to whitelist the hosted operator service along with the other 2, is similarly just update the whitelist using a transaction on chain. And there is a difference after this, which is to activate the hosted operator, which is the one that's hosted by us. So we choose all 3 different types of strategy. You click on register, and it'll be registered on chain in our backend. So this is not a transaction that you need to invoke with your MetaMask. Once this transaction is confirmed, you'll be prompted to key in a promo code, and this is important. So here, let's key in a promo code. This is a valid one. and I've successfully activated the hoster operator. In order to get the promo code from us, please do join the Telegram channel. On the help desk, I will just issue you all promo code upon you asking for it. So once you have the promo code, you can launch your own hosted operator and get your AVS running. So this is how the entire operator management process for BLS templates could be working like. And similarly for the other sides is on the right side, you can see the AVS details and also manage the AVS things as well, which is similar to the ECDSA one. Last part, I think I will just explain on the rewards. So this is actually an experimental feature that we are working on right now together with EigenLayer, which is a way for you to add your reward token directly to your AVS operators. So any one of AVS operators is running your AVS, and the software itself will be rewarded through a drip process. So once you as the deployer choose, let's say, reauth and proceed with giving out the rewards, it will just be dripped directly to them, and the operators will be able to claim the rewards. Last thing that I forgot to mention is that for the stake status, so this thing is quite interesting as well, because for us, we still need to refresh it manually on a daily basis to make sure that all the stake status of all the different operators delegates is actually being recorded. So once that is done, the rewards will be accurate. So yeah, that concludes my session, and I hope that you guys can deploy more AVS using the wizard dashboard. And hand over back to Aparna.
Hello, good morning. Thanks so much for having me. My name is Wes Floyd. I'm a DevRel team member at EigenLayer. Let me just do a quick audio video check. I'm going to share my screen with you all. Share screen, window. All right. And I'm going to try to present this in a larger view. Let's see what we can do here. All right. Let me just check real quick. Aparna, are you able to hear me okay? And are the slides coming up okay on your side? Looks good. Okay, beautiful. All right. Well, I'm going to go ahead and present from this view here, and we'll make sure you guys get a copy of the slides afterwards if you're interested. But to give you a little bit of background, my role on the EigenLayer side is to help folks building AVSs. So I'm very glad to be able to present to you guys today. And we just had a great session from Han Wen talking about how to deploy AVSs using the AltLayer wizard, which we love. It's an excellent tool to speed up the process of AVS development. So this presentation is going to take a bit of a step back, particularly folks that may have not built an AVS before, and they just want sort of a high-level overview of how do the different components in the ecosystem fit together, so that you're comfortable understanding stakers, operators, AVSs, and also why build an AVS, because you probably have some fun ideas, and we want to make sure that those ideas are valuable and that you could get a good demand and usage from the community. And then I'll give you a quick walkthrough of our UI. So once you deploy your AVS, you can go into the Haleski app and you can show up there and you can really start to see it live in the ecosystem. So let me jump in. We're going to talk about, recap on why build an AVS, what are sort of like the key values that we're trying to enable, and then some technical overview of how the pieces behind the scenes play together. So let's start with the context here. Why build an AVS in general, and why EigenLayer? There is a substantial problem in the Web3 ecosystem generally, which is around decentralization. There's a lot of applications that people want to build that go above and beyond what you can build as a Web3 dApp on EVM. And many of those systems today require centralized systems. You may have a dApp that's deployed on Ethereum, and you may have some backend systems on a cloud system. And over time, you may want to decentralize those. You may want to rebuild those so that they're more decentralized. or you may be building a new project, a bridge, an MEV solution, some other Ethereum native solution. But as you're building that new solution, you want to ensure the maximum security possible. And one of the ways of securing that ecosystem is through economic security. And in the Ethereum ecosystem, that takes the form of proof of stake. And so EigenLayer is trying to solve this problem of how can you bootstrap your new solution? How can you give it maximum amount of decentralization? How can you give it the maximum economic security, even though you might be a new project? Traditionally, that would take a large amount of time. If I was going to start a new project and I was going to start Westcoin, and how are we going to secure Westcoin? Well, we're going to have to go out. We're going to have people that want to buy Westcoin. It's going to have a certain amount of value. And if Westcoin is this massive bridge to bridge alt layer token on L1 to alt layer token on various L2s, well, if what's the security if that system was compromised? What's the market value right now of Westcoin? How do we secure that in a traditional proof of stake system? These are all the different types of problems that we want to help. And if we can solve these problems, people will be able to bootstrap new Web3 projects much more quickly with less effort. And also they'll ultimately be able to capture real value for their token, because if people are using your project and they're using your token, then it adds utility to it, it adds value to it, it just creates this virtuous cycle. So the goal is really all around innovation for the project, but bootstrapping the innovation as quickly as possible. And there's a few kind of key pillars here that we want to enable. We think of it as sort of economic security as a service. You have the smart new application or protocol that you want to deploy to your users. But we want to be a layer that adds security, that economic security specifically. And we want to bring not just the capital for economic security, but also a network of operators. And those operators are going to give an SLA. They're going to perform that behavior when you need it, within the SLA that you need it. And if they do perform it well, they'll get rewards. If they do not perform it well, they'll be slashed. And that's really the core principle behind the EigenLayer protocol. And so this is to say, as a new builder, we don't want you to have to build that network and bootstrap that capital from scratch. We want you to tap into the network that's already built in EigenLayer. We have a very high quality group of experienced operators, and Han was just taking you through how to choose from different operators in your testnet deployments, which is a powerful tool through the wizard. But those operators are ready to run your service, and they're going to run it in a very high caliber. And the protocol, the AVS that you're going to design, is going to set the conditions for how they'll run it very well. And the ultimate goal, again, is accrual to your protocol. It's somewhat similar in concept to the types of problems that networks like Cosmos had tried to solve in the past, or Polkadot, except in this case, you do not need to deploy an entire blockchain to service your app. You do not need an entire app chain. This is an AVS, actively validated service, and that will allow you to deploy all the benefits of your protocol without having to go through the effort of its own blockchain. So when you're thinking about EigenLayer, creating a mental model, the easiest place to start is 3 simple little components here. So we'll have a staker as an entity, a series of operators, and then it'll be you, the actively validated service developer. The staker is a person that's going to bring the capital. They have capital. They want to put that capital to use, and they're going to expect some return. They're going to put some amount of risk along that capital, very similar to restaking in core Ethereum. And there's going to be operators. Operators are professional shops, or maybe they're actually solo operators who are very good at running this software on your behalf as an operator. And they have the available capacity. They want to earn a reward. It's very much like Ethereum validators, except in this case, they can run any software. And the software they run is a software you develop. It's the AVS. So to put this together, the restaker will delegate their stake to an operator. It's a very simple autonomous thing. The staker could stake alt layer token, they could stake your token, they could stake native ETH, and we'll get into staking mechanics in a minute. But all that gets delegated to a single operator. And the operator is getting delegations of stake from many different people. They're getting stake delegations from retail people on the internet. They're getting delegations from institutional capital, just a lot of different places, but they have a sum total of capital. And then the operators will be registering or opting in to multiple AVSs. And In today's world, they're opting in AVSs. In the near term, in the next couple months, when we enable slashing, which is the next big upgrade of the protocol, they will choose different portions of that stake to be allocated to different AVSs. So we don't have to worry about that for today's sake. And the simplest scenario today, those operators will be running your AVS. As an AVS builder, you'll want to think about a couple things. You'll want to think about which operators do I want to recruit to run my AVS? If it's a testnet deployment, you may just want to run your own system. AllLayer has their own operators they can run for you. It can be kind of trusted. Over time, you want to build relationships probably with these operators and communication channels so that you have ability to support them running your software. You'll also want to determine which staked collateral you want those operators to run on your behalf. And Han was showing the scenario of how you can add your own restaked asset. So you have Westcoin coming in, building West AVS. Westcoin is going to be the restake collateral for my AVS. And in that scenario, I might want operators to just restake Westcoin. But there is a lot of flexibility in the decision about which assets should be backing your AVS. In today's terminology, we refer to it as a quorum. So I can have a quorum of Westcoin, a quorum of AltLayer token, a quorum of Eigen token or Ethereum. And there's a lot of flexibility. I may want different behaviors for different quorums. If you had a chance to see some of the new protocol research, we're going to refer to that as operator sets going forward, but it's going to be functionally the similar concept. So not only will I have my AVS that's serving that purpose that I care about, but within that AVS, I can have different sets of assets backing the AVS. And this is the most simple AVS architecture that we can share just to kind of get a sense of the end-to-end flow. The AVS will be serving your end user or consumer. We refer to these folks as AVS consumer. They're an important pillar in the ecosystem. And that person could either initiate a task on chain. They could say, hey, I have a new request. I want to bridge some assets, and they're going to reach out to your AVS. Or they could initiate that task off chain. They could just reach out to the operators directly. For the simplest scenario, let's say they have a new task. I have some assets that I want to bridge. They reach out to your AVS contract. Your AVS contract will be an extension. It will be integrated with the core EigenLayer contracts on Ethereum L1. Those operators will be interacting directly with your AVS contract. They will register to your AVS contract. In most cases, like the example that Han shared around the BLS signature AVS, their aggregated signatures will be written back into this AVS contract. So it's kind of a central point of control for the AVS. This mechanism here of how the AVSs interact with the operators is entirely up to your decision in terms of how you want to design it. The AltLayer team and the Wizard has a really nice set of templates for you to start with, which are most common. Those templates cover, 80, 90% of the most common scenarios for AVSs. This interaction here might be much more complicated. There might be an aggregator in the middle. There might be other scenarios in how they interact. But in general, there's some off-chain and on-chain communication for your AVS. And then lastly, again here, your end user consumer, they may not choose to start tasks on-chain. In fact, for EigenLayer's in-house AVS, we built an AVS ourselves, partly to showcase how to build an AVS, or a good example of an AVS. That AVS is called EigenDA. It's a data availability solution. That AVS, the user initiates communication off-chain with the operators. It goes through a disperser. It's specifically for layer 2 rollups. And that's just another example of a different way to start the communication. Ultimately, though, even in that scenario for EigenDA, the user's blob request gets wrapped up in responses from the operators, which ultimately gets written back on chain to the AVS contract. So it does tie back to the AVS contract eventually, and that's sort of your anchor there mentally. All right, so we talked a little bit about shared security before, and this term will get thrown around a lot. Prior to EigenLayer, all of these services had to be their own separate networks. You had to have different sets of operators. You had to recruit different sets of capital. So Westcoin had to have its own set of operators, and we had to start its own network. It was very time consuming. You have to market to them. And then every other network, every other purpose and application had to repeat the same process independently. The goal of what we're trying to solve here is to bring all these folks together into a single network so that when I want to start my new protocol, my new application, my new service, I already have the operator network ready to go. I already have the capital base available. We're bringing everybody together. And then my service is just a service that I plug in on top of this model. And so if you go to the original EigenLayer white paper here, it's available in docs.eigenlayer.xyz. Check out our white paper there. You'll see this sort of a diagram. And in this diagram, it's describing the purpose of an AVS in relation to Ethereum. So prior to EigenLayer here, excuse me, in Ethereum here, you'd have multiple AVSs here. So you'd have a service that was part of a dApp. All these services had to be independently secured. If Ethereum had $10 billion in security, each AVS would have to raise $1 billion worth of its own security here. So what EigenLayer is doing is it's increasing the cost of corruption here, so that in order to hack or to maliciously interfere with any of these services, the COC or cost of corruption is much higher now, because we're actually pooling the security with EigenLayer from Ethereum. And all that means effectively is that if you're going to build something that's very sensitive, very secure, a bridge that's going to secure billions of dollars of assets, or some compute layer that's going to be an input to a very high value DeFi protocol, you have a much larger capital base you can tie into with your pooled security. So let's take a quick tour through the UI here. I want to give you guys a sense of the EigenLayer app, so you can kind of triangulate all these pieces. If you go to app.eigenlayer.xyz, you'll be able to see the mainnet version of the EigenLayer app, and you can see how much TVL is staked, and you can actually interact with there. You can restake. But for the purposes of today, let's go to holesky.eigenlayer.xyz. That's our testnet instance of the app. And this is a place to start thinking about kind of triangulating those three entities that we talked about. Here you can see that we've got a bunch of different assets that are whitelisted in the app for people to stake. You can stake native beacon chain ETH. That's its own process, taking your Ethereum validator, staking it. You can stake Eigen token. You can stake AltLayer as an example. It's a great asset to restake. And you can see there's other assets here that people are adding consistently. Because even though we have whitelisted assets, you can add your own asset for folks to restake for your protocol as well. Once you restake those assets, you will choose a single, the end user, the staker user will choose a single operator to delegate to. So I'll go to Everstake as an example here. I'll choose delegate, and all my assets will now be delegated to this single operator. And then what would happen here, ultimately, as you can see, these are the AVSs that I'm securing. These are also the AVSs that would pay rewards, both to the operator and to the staker, ultimately. And so as you're shopping for operators, this is a way to navigate, which assets are they securing currently? Which other AVSs are they involved in running, and those sorts of things. And lastly, Han Wen had showed this set of instructions. I'll pull it up in case you would like some triangulation here in the EigenLayer docs. You may ultimately want to onboard your AVS to the dashboard in the Holesky app here. So you'll follow these instructions, and you'll go through this process of onboarding your AVS to Holesky dashboard. And then your AVS will show up here in the list of AVSs. And this is how you can actually see your AVS running live. It's got some metadata here. It's got an image for your AVS and some metadata with description, things like that. And then from the AVS's perspective, you'll see all the operators that are registered and opted in to that AVS. And I think the wizard does a really good job of helping you manage these operators. So I would default to the wizard as much as possible, but you can actually validate what's going on in the Holesky network also here for a second perspective. All right. The last thing here that's very recently been enabled is rewards distribution. So you can submit these rewards to your operators and stakers today. There's also some documentation if you go to EigenLayer contracts. I'll just briefly reference this in case you guys want to dig deeper on how to find this information under docs. We have a lot more information here about our rewards coordinator. And that's actually some kind of underlying contract details there. We also have some details if you're curious about how rewards payments work. If I go to rewards guides here, there's some details about how to see the distribution data and how often rewards are sent. The wizard is the best place to start, but if you want more background on the mechanics of how often the rewards are distributed, lots of information for you there. Slashing is not yet available in the protocol, but it is coming soon. We've got some blog posts on blog.EigenLayer that talk more about our designs for it, and we're very quickly pushing to get slashing available. In the V1 of slashing, it'll just be effectively, if the operator behaves maliciously, we will slash a small portion of their stake programmatically. In future versions, though, we want to enable things like stake sure, which could actually route the funds that would be slashed to the harmed parties. So if someone's protocol was hacked and a user lost funds, stake sure V2 of slashing would ensure that those funds get back to the person that was hacked, as a novel way to manage that. So that's pretty much all I have to start with right now. I do want to give you some inspiration. There's a lot of fun different categories that folks are building. There's roll-up services. AltLayer has been a tremendous partner and an early innovator in this space in servicing roll-ups. EigenDA is the name of the AVS that we built in-house, but there's lots of fun other projects people are building to solve problems around MEV, keeper networks, decentralized sequencing. And then moving into the right, you see some folks trying to solve problems that are more traditional computing, like AI inference or general purpose databases, general purpose compute. There's all these interesting solutions that are building trusted execution environment networks, off-chain proving. And one last consideration, as you're building your AVS, you may choose to build all of your AVS on your own, just an independent AVS. Your AVS may also depend, you may want to build it so that it leverages other existing services. So for example, if your AVS needs fast finality, you may want to plug it into AltLayer Mock AVS. If it needs proving, you may want to use a prover network. So your AVS could be on its own. It could also be using other Lego bricks of other AVSs and be sort of a compound or a hybrid AVS there. And that is pretty much all that I have for right now. Last thing I'll share is a quick advertisement for Build on Eigen, our Twitter account for my team, the DevRel team. We post a lot of information there about all the new stuff that's getting released, updates to our code, so you guys can stay in touch there. And that's all I have for now. Aparna, I'll hand it back over to you unless there's any questions, but thank you so much for letting us present today.
Okay, so I think I have about 20, 25 minutes. I think that was really great, Wes. Thank you so much. Really interesting. I've learned a lot just watching it as well. So I'm going to talk about something that's maybe a little bit higher level here, but I think it's very helpful to kind of understanding crypto and how EigenLayer is going to really help all of us who are building AVSs really propagate open technology and the overall tech cloud into this post-crypto world, with EigenLayer playing a specific part, very thin, small part that really lets other people shine. So the main two ideas in this talk is, first half is going to be, or maybe the first third is going to be about open tech and the Web2 cloud, just to level set everybody to like where we are, how we got here now. And then the second part, last 2/3 or half, is going to be really about where crypto and EigenLayer is going to change things. I'm going to drop off for 1 second and just make sure. Okay, nobody's complaining that anything is going wrong, so I will continue. Okay, so starting with the the first part. So I just like to put up a chart sometimes just to kind of give a little level set about what has come along so far leading us up to Bitcoin. Because a lot of us, you know, in the Bitcoin field will get very focused on what's come here. I would argue that there's been a long progress of proprietary to open, with fiat money and Bitcoin really being, and then all of crypto and blockchain afterwards being the latest thing that really completes a lot of the problems that haven't been able to be solved by previous things. But if you look at it, networking, then internet, mobile, software going to open source Linux, straight up hardware to virtual machines, Kubernetes, extracting that, and then data centers going to big open public clouds. Those all have been trends towards open. Now, when we add Bitcoin and ETH and crypto and all of these other things here, we actually see we can complete the whole picture, and everything that we're all building is going to basically move the technology footprint to a level of openness that's never been possible before. And I just jotted down my opinion on some tipping points for things up till now. You'll notice I actually didn't put tipping points yet for any of the crypto technologies, just because I think to really say we've gone to a tipping point means that we've changed substantially how we run the world. Like mobile phone and iPhone and Android came much later after cell phones were invented, because that was a tipping point where all of a sudden the phone became a computer and the internet. And I think we will be having those soon, sooner than a lot of people might have thought, but we're not quite there yet. So just giving people a little bit of mindset is like, what does it mean to have open? Open means that you get some kind of stack. You're able to standardize it. You're not stuck with particular technologies. OSI model was a early open stack for networking that researchers invented, and then TCP/IP was inspired by that. That's what we use in internet now, but there were like 15 networking standards before that that were all proprietary. So that's one good example. Hardware software stack, everybody here is pretty familiar with. Like you go from very low level hardware to middleware, runtimes, and then finally to software as a service. That was on site. And then over time, we eventually got the cloud, which was infrastructure as a service, platform as a service, and software as a service. And the reason I put a slide like this up is that although crypto and blockchain are super important layers, they imbue tech with money, they imbue tech with value, with digital scarcity, they still do have to actually fit into this picture. So they have to relate to everything else necessary in technology. And I try to keep that mindset when we think about how blockchain fits into the overall stack. In the current world, I just like to point out in the level sets of the past or up till now is that cloud platforms really control the market for open source software. Between the top three, you're already over 70%, Amazon, Azure, Google Cloud, and then you do the international clouds. And it gets to be quite a bit. It's approaching $1 trillion of revenue last year. So it's not tiny. We hear DeFi numbers of trillions of dollars, but that's actually just money kind of moving. This is actual revenue, people paying for things. So it tells you that software is worth a lot. The only challenging part we've had with the value of software is that all of us here develop software, build companies, build whatever. We develop our stuff open source, and then I kind of show the original model was that the open source developers would finally make a product and sell it. And with the cloud, we kind of lost that because the cloud vendors learned that they could just take open source software, wrap it inside of their own little package, and then sell it directly, which is good. It helped to build the cloud, but it's really bad for developers because it's meant most of the people who work on open source haven't gotten the value. The crypto cloud is showing a new way. And again, this is a place where I think EigenLayer is really going to play into. And, we're seeing this already for blockchain. Blockchain and crypto is one of the best, beautiful places for developers. You build something, literally, you take your software, make a protocol, release it out to the world, attach a token to it, and the value goes back to the team and everybody involved. It doesn't run the same risk that everybody had in the Web 2 world where your open source software would just be sold by Amazon or one of the other major clouds. So, and just showing an example, this is actually just a small subset of what Google Cloud offers, and a huge amount of all of these different kind of SaaS platform infrastructure offerings on their public cloud are actually open source projects that Google did not develop. They just wrapped around. So that's basically taking, value that, developers that are on this call here would not be able to get because the cloud provider is getting all the value from it. So, so I have this slide that I kind of show here, which is just building it out. The architecture of clouds, that's what everybody, the cloud providers kind of focus on, is decentralized. Yes, that's true. But who actually controls the value? Who lets people put in hardware, software to like get value and then control the monetary flows to capture it? That's all centralized. The public cloud providers tightly maintain that behind APIs, make it very hard to like mix and match different cloud providers, make it very expensive to pull data off, 99% gross margins on taking data out of a cloud. So very rent-seeking type behavior. So what we really want in the Web3 cloud is we would like to, for everything we're building in blockchain and crypto, yes, we want to also change, of course, first the finance system, and that's been a huge part of crypto so far. And here I'm talking, to developers and people building AVSs here about like, with crypto and with EigenLayers assisting this, we really can think about a fully decentralized stack. Decentralized is important because that means any of the billing systems, the pricing, the revenue access, all of that is getting projected back into crypto developers and their projects. And, it's not only the $700 billion revenue from last year, it's growing this year already. And we all know, I think it's not a big contentious thing to say that AI is going to dramatically increase the footprint of what you can do with technology. So it's going to even unlock a lot more revenues. Okay, so that was the precursor. That was good. That was about 7 minutes. So now let me jump over to the OpenTech and Web2 cloud. I'm just going to take one quick break and take a look. Okay, no new comments. So, okay, so let's go back here. Okay, so that was the background info on, a little bit of the history of open source, how it's been applicable to the Web2 cloud. Now I would like to basically talk about when we're looking at crypto and EigenLayer, what that means. So, okay, so this is the build for this slide. So I think in the crypto space, it's helpful to think about the evolution of open innovation and opening up the stack more over time. So this slide has been one that Sriram has used a few times, so I pulled it off his decks. It kind of shows that the original Bitcoin created this open value system around the Bitcoin token. But everything that was built in it was basically a monolithic software stack. So the security of the proof of work mechanism, the consensus of the peer-to-peer software that miners would run, the execution of the very simple scripting language, and then the final application of transferring money around, that was all one thing. And during the Bitcoin era, you had many different kind of colored coins and other forks of Bitcoin, because anytime you wanted to change the behavior of a blockchain in that era, you had to recreate all of it. So enter Ethereum around 2014, 15, and finally launching 2016. Ethereum added this core open innovation idea that you could make the execution layer, basically the proof of work consensus was pretty much the same as Bitcoin. But the execution layer would now be a Turing complete VM. And that meant that software developers like us could actually create any kind of application they want. So you got your application. The roll-up era, starting around 2019 or so, that added another layer of open innovation, which was now you can have different roll-ups. They could have different ZK VMs. They could have, Fuel VM. They could have even Solana style or some kind of like highly parallelized VM. Or now we're seeing with EigenLayer getting, to those levels of performance and beyond with different projects that are building AVSs on EigenLayer. So, what EigenLayer has done is it's taken this idea of about security, which is bound to just one chain, and it's allowed you in a completely portable, completely trustless way, exactly the same kind of level of security of what you have inside of your original chains, to use those tokens and that value in a shared security setting. And so the one new thing that's been created here with EigenLayer is now this consensus layer. So the actual nodes that are running some kind of consensus peer-to-peer node software, those are now generalized. So you can have, not just like, an Ethereum type thing. You can put together consensus around large computing networks. You can put consensus around things that are doing large storage networks or, certain types of like security multi-party protocols. And of course, you can really generalize out what you're doing with rollups and have a huge amount of like, rollups plus all sorts of tied together apps that are tied onto a completely shared security setting versus just being bound to one chain. Okay, so so in order to do this, this is not a small feat to do. EigenLayer, I kind of put it in the middle, but there's actually 4 sides to the marketplace. We were just talking a lot about the AVS side, but just quick kind of go through. The 4 sides are stakers bring in their tokens, the value that they'd like to actually get some additional rewards for. And similar to staking with Ethereum, they stake it with operators now who don't just run validators on Ethereum, but they run basically validators for any AVS's consensus protocol. AVSs write their software. They basically hand it off to operators, just like Ethereum hands node software to validators. And then these two basically, use the operators to run the protocol. The AVSs then deliver their service to consumers, which might be end users like you and me, or it might also be other AVSs, people who are on this call who are building other services and would like to use kind of as a middleware, an AVS software package. That's like software as a service, platform as a service. So, so what do operators run? Just kind of giving, from a high level, just overview talk on this. They can run a bunch of different types of software on different types of hardware. They can be paid or slashed based on what AVSs think is the right thing to do. Like, I don't know how many people really followed a lot the consensus protocol of Filecoin, but that's a totally different kind of protocol. Proof of space-time, not proof of work. You just have to prove that you hold data over some long period of time. And, in something like, data availability, you're just proving to a group of people that you publish the data sufficiently. So very different sort of things, very generalized protocols can be pushed out there then. Really the credit on EigenLayer, we build something that's very thin, very open. All of the innovative work that's, being done is AVSs that are running on a large set of these operators. And, we're familiar with these from existing Ethereum spaces and others. So we should expect, a very robust set of operators in the space. So just checking in, I want to make sure if anything has come up. No. Can I get a heartbeat that everything's still going okay? Yes. Okay, good. Thank you. Okay. So this is an AVS category map. What sorts of things somebody might want to actually build. And it's a lot of categories are on this map. But remember, when I was showing Google Cloud or others, like to actually build a software stack for Web3, like crypto actually taking over the entire software technology world that we've all been living in. That kind of requires covering everything you saw on that Google Cloud thing eventually. So everything that's available on Web 2 will be available on Web 3. Like that is, I think, a firm truth in my mind. So a year ago, Shriram was mentioning these are all categories that should be created. It's like Vitalik talking about open problems or other things. And, it's amazing to see just how much innovation is out there that people want to build. There's somebody building in every single category that Shriram mentioned a little over a year ago. And another way to look at it is, playing on AWS invent or reinvent. If you look at from a category basis, within categories like decentralized physical infrastructure, we've got a number of people, roll-up services, cryptography, fully homomorphic encryption, DeFi, MEV intents. There's just a huge open field. It's a little bit like when public clouds first kind of emerged. Like we finally got the right product market fit that everything that we have in crypto and all of the value, all of the security can now be expressed in general purpose software as we're used to with the cloud model that we have already. This is not Dfinity where somebody is saying you have to figure out a new language and you're inside of a closed system or others. This is just build in Linux, build in the languages you want, build peer-to-peer node software, run it with operators, and you're good to go. And if you're in the blockchain space, you have a tremendous amount of middleware that you're assembling together. And then all of us together in blockchain offer more and more services to regular software developers who right now are building to Web 2 clouds. So, okay, so I'm kind of mixing some of my Web 2 thinking, but let me drop back here to like unbundling the 3 dimensions. So this is an important point. Like in Ethereum, you had this idea of a consensus client, an execution layer client. You had these light nodes, they're called, right? Because they were just Raspberry Pi, simple simple nodes cost a couple $100, which became funny after a while that you had a $200 hardware footprint running $100,000 worth of stake. But that's Ethereum's version for decentralization, which is a great model for layer one, where you need to have absolute trustless decentralization, very, very hard to hack. In EigenLayer, instead of having a set amount or a lot of stake or one token, EigenLayer, the stake in the shared security is any token, any ERC20, any ETH, anything that can be bridged into the Ethereum space. The node requirement, arbitrary node requirements, I'll say a little about that in a moment, and then the software. So, there in the tokens, you can see really just anything that we've had in crypto so far. This is the big open unlock now for tokens matching to like where people would like to use them. Arbitrary nodes. So, for a simple thing like Ethereum, you had light CPU, you had light SSDs, and you're kind of done at that point, some bandwidth. But with EigenLayer, you might be bringing a huge amount. There may be people that you're utilizing through AVSs that are expressing massive GPU farms. You may have trusted execution environments like enclaves and others that people are bringing in a trustless blockchain protocol wrapped around it. You may also have footprints where you basically are requiring that the software is being run on cell phones. And with things like in the DPIN space, for instance, witness chain, you can actually have proof of machine, proof of location type things that are augmenting proof of humanity. And the software to run now has expanded out to not just things that are in the crypto kind of Web3 world, but this is really projecting it into Web2. So for people who have been around for like 2 cycles, there was kind of a push on this back in the 2016, 2017 ICO craze. But similar to the blockchain monolithic stack, if you wanted to create something like storage, you had to create a new Filecoin VM, a new Filecoin token, a new Filecoin blockchain. Now this basically says anything that you wanted to do that was so complex before now is a very simple assembly of security tokens, operators, give them some incentivized peer-to-peer network, and now you've got a service that you can deploy. It's like basically making a Web3 crypto cloud a full reality for people. And so that's our view. I mean, it's it's only limited by the imagination, the innovation and capability of developers, which is a bet I'll take any day that people are going to be able to do that. So how am I doing on time? Can I cover a little bit more advanced topic? Yes. Okay, great. So if people want to go into a little bit of the innards of the Eigen token, I'd like to just give people a perspective, because I try to learn by differentiation, like what's different, what is unique that I should know about in comparison to what I've known before. And so everything that I've talked about you before up till now is definitely super valuable. The Eigen space is kind of marketplace bringing these all together. And there's a lot of momentum to our product, and there's a lot of, I think, momentum really to the credit of the ecosystem and people who have just kind of voted with their feet and joined into this like fast growing market around shared security and around like very open innovation of new protocols in the AVS model. But Eigen token itself has added a new superpower to crypto. It's something that really did not exist before. And I think as people building AVSs and developers, it's good for people who have seen it already. Just bear with me. It's just a few slides. But for others, it's great to see the first time. It's a lot deeper than what I'm going to show on these slides. But let me just give you the top level parts, and then you can always learn more by going into like specific presentations or even the white papers where Sriram and some of the core researchers like Schaubik and Gautam really described how this works. So, okay, so slashing for human observable tasks. What do I mean by that? In crypto to date, slashing that we've been able to do in proof of stake protocols, adding this beautiful idea of like stake and slashing, has been for on-chain observable tasks. And the reason for this is that a chain is a mathematically provably correct execution environment. So it either is like validity proof with zero knowledge technology, or for things like Ethereum, everybody runs the same L1 EVM software, and everyone has to agree that the global hash of each block is exactly the same to the bit. If it's not the same, then people will basically say whoever posted it is lying and it won't proceed. So it's on chain and it's observable. You don't need to like trust another person at all or participate with them or have any kind of shared belief to it. So these are the types of things you can do with human observable tasks. The L1 slashing by, slashing by chain fork, and for something like Ethereum, I didn't realize we didn't have this down here, but like the typical ones are like either you're not actually posting blocks, and so you start getting slashed for like inactivity. Then the other one is you vote valid for 2 different forks of the chain at the same time, and that's called equivocation. And then you get slashed very aggressively for that, because that's literally an attack on the chain you should never be doing. But they all have this property that it has to be a mathematically observable, provable task that you can show on chain. So the L1s have the superpower, which is slashing by chain forking. That's the reason why you could have BTC and Bitcoin Cash. And that's the reason you originally had ETC. And ETH that we all know now is actually a fork of the original ETC chain. So you can have these slashing by chain forks where, you know, people kind of move things around and decide that this chain has the real token value, this one does not. So EigenLayer does not have this, this L1. EigenLayer literally is not a chain. It is just like a security accounting marketplace that builds on top of Ethereum to allow all tokens to participate in this 4-sided market. But the breakthrough of the Eigen token is that it adds a new crypto economic primitive that we haven't had before in a general way. I will just say a detail here is, if you're familiar with Augur from many years back, Augur did incorporate this idea in a specific way for voting quorums, but they did not make it a general purpose slashing work token. So slashing by token forking. So the value of this means that, similar to like Ethereum or others, if somebody is observing something wrong off chain and you believe that they've done this incorrect behavior, then it is possible off chain to essentially say that we are going to fork the Eigen token, and there will be an off chain effectively voting by people based on which fork they want to go with. People that are on the losing fork are the losers, and based on people observing them doing something wrong, will be the ones that experience the slash in the resultant fork. So let me actually try to say that another way with some examples here. So if you are building AVSs and you're doing complex fraud proofs, you can do gaming VMs, you can do databases, you can do all sorts of things that are just mathematically provable on chain. And you can secure those with ETH as well as any ERC20s that are in the wide world of the crypto space right now. The things that are hard to do is these not mathematically, but off-chain human observable faults that you really can't prove on chain. So data availability, I don't know how many people have looked into this, but data availability has this very particular thing, which is called the withholding attack. If somebody does not actually post data and somebody calls them out and says, oh, you didn't post the data you're supposed to, the person can post it at that point and say, oh, you're saying I didn't post it, but I did. You're just like implying it, even though I did in the end. Because the timing aspect of data availability is very hard to define to like a completely separate observer. But if people are participating in the data availability protocol, it's completely obvious to them. They just can't prove it to somebody else. So off-chain, the people that are running data availability protocol can in fact enforce by slashing of token forking people who are misbehaving from a withholding attack basis. Prediction markets, things like oracles, the price of BTC, you really can't prove on chain that Bitcoin is not $5. I mean, everyone can agree, but then you're trusting Chainlink or somebody else to actually be giving the right number. If right now Chainlink was hacked and they started putting the wrong number in there, it would be a massive problem in DeFi, because everybody is completely dependent on oracles providing the right information, and there's no crypto economic trustless security at L1 on this. We've kind of stepped back to the Web2 world where we're trusting an outside provider, and everything going on in DeFi is dependent on that right now. Whereas with the Eigen token, it's actually possible to have prediction markets where there's a fixed cost of corruption, that if people are observing someone posting a $5 instead of $60,000 Bitcoin price, there can be a slashing event associated with that kind of wrong behavior. And then we have other examples down here. But the core idea is that things that are hard to prove on chain, therefore there's no like mathematical proof that can say / this person do this. Off chain, you can raise a flag, put down a token forking / bond, and then everybody who's in the protocol can say, yeah, thank you. You put that fork event in. I recognize that there was somebody attacking the chain and doing something wrong. Then this off-chain voting is effectively enforced through the slashing by token forking contract mechanism that's in EigenLayer. And now you have a general purpose work token that allows you to enforce this much larger class of possible slashing conditions. So, the 4 sides, bootstrapping, I'm showing at this version the Eigen and the token forking. It adds this unique capability to the Eigenplace market. And it complements the reward slashing and the programmatic incentives that you get with regular tokens. Okay, thank you. Okay, bye everybody. Thanks for listening.
Thank you, guys. Okay, so thank you. Hope you're enjoying the session so far. We'll get some of the other guys come in, and then we'll have a quick chat about some of the things that excites us. So we have Junhao and Hanwen. Hanwen we have met before. Junhao leads product development. He's also, I guess, the man behind Wizard, if that's the right term to use it. So he's intimately familiar with Wizard, and we'll have a chat about if Junhao and Hanwen had all the time in the world, what they would build in terms of AVSs. But before that, let me give you a quick rundown of what we have so far in terms of, if you're looking for an idea to build, let me share my screen so you can see. We have compiled a list of interesting ideas. So a gentle reminder, this is the devfolio link, so avsthon.devfolio.co. This is where you have all the details on the hackathon itself, and towards the end, and of course the prize money. And towards the end, you would see the Hacker's Guide. And if you go to the Hacker's Guide, you'll see this, this Notion page, which again tells you all the details around how the hackathon will work, the timing and the timelines, the rewards, and so on. And again, towards the end, you would see, and by the way, there's a list of categories that we put in, which are higher level categories of things that generally excites us. For example, what we call composable AVSs. So if you look at all the AVSs today, they kind of sit alone in some sense. So for example, you have Lagrange, you have Mark, and you have a bunch of other AVSs that kind of sit alone today. And the idea would be to build something that would compose with other AVSs that already exist. So imagine something like a DeFi Lego, the way you see in the DeFi space, where you can use Aave with Uniswap and you can compose different DeFi, DeFi applications that way exist. The idea would be to build something that would compose existing AVSs. There's one category that we call consumer-facing AVSs. So these are AVSs that are directly impact or directly engage with an external user. They're not simply middleware service providers, but actually consumer-facing AVSs. The last one is called what we call replicable AVSs. So these are AVSs that you could deploy in certain contexts. So for example, if you look at rollups, for example, so you have Optimism, which is the Optimism mainnet, and then you have you have OP-Star that allows you to basically fork Optimism mainnet in an application-specific context. So you could imagine certain general-purpose AVSs. So for example, a Chainlink like Oracle service that's a very general-purpose service. But then you could imagine a fork of Chainlink in some way that serves a certain dedicated kind of feed. So for example, imagine you're building a carbon credits platform and you need purely some data, some feed that helps you with that carbon credit application, and then you could build an AVS that is basically a fork of a general purpose Oracle that serves you that specific feed. There's also an interesting category that we called ephemeral AVSs. These are AVSs that are short-lived. Imagine AVSs that where you borrow liquidity and security from Ethereum, but only for a short while. So yeah, these are kind of a broader sort of higher category of AVSs that you could imagine. You could come up with specific application in those categories, but you also have a wish list of AVSs that you could imagine. So these are very concrete ideas that you could start with. And it's a list that, again, spans different categories around, AVSs that use EigenDA, AVSs that are deep in focused, AVSs that are targeting payments, AVSs that are more generally DeFi and RWA focused, and gambling and social and others. So again, these are things that you could find directly by going through to the devfolio. And if you click the hacker's guide, you would have, and towards the end, you will see what should you build. This section lists you all the AVSs that I think are interesting. So now let me go back to removing the screen, and let's have a chat with Jonah. So Jonah, if you had all the time in the world, what should you build?
I think the most obvious use case is actually DeFi. DeFi has been, we went through the DeFi summer, and I think DeFi is still an important use case within the crypto space. So I think there is a lot of intent-based bridging, especially they use the standard, which is the ERC-7683. I think we can easily use this ERC-7683, modify it, and turn it into an AVS. So in this case, your operator can become your bridging fillers to fill all your orders. So I think this is one very simple, one very straightforward use case that that can be easily implemented, and that can also have a very big impact. Also, you can think that this although this is just like one AVS, but it can also be spin out into multiple AVS. That means if someone wants to spin out their own intent-based bridge AVS, they can take the same code base and reproduce the same thing. Then after that, contact the same set operator who want to be the filler and fill in all the orders and so on. So this is one thing that's really on top of my mind.
Understood. And Harman, I think we discussed, I think a couple of weeks ago, around some of the ideas, and one thing that you mentioned was that I recall very clearly is that deepin is one area that hasn't been explored that well. And so could you kind of explain that a little bit more, and why you feel like deepin is something that should be targeted from an AVS perspective, and what exactly would you build if you had enough time and resources?
Right. First of all, I think just going back to what Robert and Wes has said is that most of the coordination networks that we see today should actually just focus on building those networks and the physical infrastructure in the case of deepin, instead of focusing so much on consensus, how to do incentive mechanism, rewards slashing, to make sure that the operators do their job properly. So this is the reason why I think AVS comes in the way that it can shine, because you don't have to build all this by yourself. You don't have to build a layer one just to make your deepin work, and you don't have to worry about consensus and bootstrapping of nodes, because those node operators have direct incentives through the EigenLayers mechanisms, and you can handle that everything as we've shown you through the demo, through something like a wizard dashboard. So that's the premise, and I think deepin itself is very interesting because first of all, you have those that are like virtual, which we do see now sometimes nowadays. Like for example, file storage, we have Filecoin, and we have, for example, ZK coprocessor and also TE as well. Those are virtual kind of services that you can offer with deepin, but there are also physical ones that I think are under leveraging the AVS like mechanism. So, for example, we see some of those wireless network mechanisms, or for example, you have weather data, trading of air rights, recording of flight data, and all those things. Those are things that you can actually bring onto deepin. And basically just leverage on that entire mechanism to scale widely. So I do look forward to see more of such things experimenting within the EigenLayers ecosystem, and as well as with AutoLayer as well, instead of them actually building on top of a layer one solution, which is a bit actually more complicated because you have to build on-chain smart contract services yourself, as opposed to like relying on the off-chain node services to do most of the logic. So yeah, that's where I think it will shine.
Understood.
To add on to Harman's, right? Sometimes having a fully on-chain might be overkill. You might just need an AVS to do your job, do your function well. So yeah.
Okay, so we have about 4 minutes left. So I think one thing that I wanted to ask you is, given that we expect people, would like people to use Wizard as much as possible during this hackathon, and of course that we hope and we believe that it will save a lot of time while they build some of the contract stuff or even off-chain components. Beyond what Wizard offers today, because they may find some feature that's missing. Beyond the features that exist today in Wizard, what are the things that we're planning for the next few months or so in terms of feature set for Wizard?
Yeah. So one thing is the rewards. Just now, Herman went through the rewards features. You can see that you can actually issue rewards, initiate the reward process. So we would like to see more things like whether can we do reward simulation. That means before you even issue the rewards or initiate the reward, you can simulate it and try and see is that reward what you expected. So that's one. And also post reward while waiting for EigenLayers, stereo to be generated and stuff like that. Can we also verify those information ourselves? That means rather although EigenLayer will generate stereo and post it on chain, but can we also double verify all this stuff also? And also on the user interface side, right, we want to make it more granular, much more control over the reward mechanism, very down to a specific things like controlling the weights of each strategy you want to rewards and stuff like that. So that's one feature that we are also looking into. Yeah.
Cool. Anything, Harman, from your side that you would love to see some features in?
Yeah. So the last thing I wanted to add on is that for the operator side, we are also working on more features. So in future, we hope that operators will be onboarded almost permissionlessly. They will just go into an AVS and see that they want to run this node software for you, and they will just opt in and run the Docker image on their own bare matter infrastructure, or they can use any cloud hosted services to do it. And in that way, we can actually have a lot more operators onboarded, just instead of just the whitelisted ones that we know of, like the one that are reputable. So that will be interesting in a way because, as you know, blockchain usually cannot scale really well if there's a lot of node operators to communicate with each other, and that's where an off-chain communications with AVS nodes operators, it will be very interesting.
Yeah, cool. I think we are almost time. So again, a gentle reminder: we will have some presentations coming up right after this from the bounty providers, so Lagrange, Brevis, and Automata. So those are coming up right away. But yeah, thank you very much for tuning in, and thank you, Junao and Hanan, for this short session. And so over to you, Aparna.
Hello, everyone. Can you hear me? Right. I think we're on. Good. We've had the confirmation. Everyone can hear me. Hello, my name is Angus. I'm DevRel at Lagrange, and I'm here today to talk to you about our bounty in the AVSthon, the AVS-athon? No, the AVSthon that AltLayer are hosting. Thank you very much to AltLayer for having me on. So, what is Lagrange? Hold on. Usually I can use my arrows, but I need to click on the little button here. What is Lagrange? Lagrange is a collection of things, different protocols. So there is a proving network where people can service, kind of generate ZK proofs for people who need them generated. There is something called state committees, which can generate state proofs. And the third one, which is what we will be getting people to build stuff with during the AVSthon, is called the ZK coprocessor, right? And so these things all kind of related in ways, but we're mainly focusing on the ZK coprocessor today. So what is the ZK coprocessor? It basically allows you to do SQL computations over data, like on-chain state data, right? So you can query large amounts of like historical state data directly from smart contracts. And the way that it's kind of set up means that the system only generates proofs for things state which has changed kind of on the back end, which means that it's more efficient with your compute power, with the compute power of the nodes in the network, and also it's very fast, right, to get your results for like the proofs for the data that you want to compute over. So what does that mean for you as a developer? Well, it enables you to do scalable and like cheaper off-chain compute for data for your smart contracts, and that means that you can build apps that leverage the contract states that you want to track in a more secure way. So the prover network that I mentioned earlier is comprised of a set of restaked provers on EigenLayer. So, there's a lot of, as you can see here, a lot of network participants and node operators who contribute to the ZK prover network. And that's where the kind of compute goes on for the ZK coprocessor. So as you can see, there's some impressive numbers there, 10,000 queries per week and more than 400,000 proofs generated per week. So that's just to give you a little bit of background and how it ties in with EigenLayer. So as a developer building something with a ZK coprocessor, you're going to need to know how the whole system works. And so there's basically two stages, right, for using the ZK coprocessor. And it says here that the Lagrange proving network, that's where all this kind of stuff is happening, right? So the first step is pre-processing. So what you do is you choose a smart contract that you want to index, right? So you choose the kind of the smart contract and what state you want to index. And then the Lagrange network will start pulling that data out every block and start to put it into the ZK friendly database, right? So this is where I was saying they kind of change, and I can share a presentation if you're interested with a lot more technical detail on this, about how it kind of slots it into this ZK friendly database. And then the second stage is once you've indexed a lot of data that you want to look at, you can basically provide like an SQL query, and you can crunch this data that you've collected over the historical state, right? So that's a lot of database. So it's you can query a lot of data, and it's quick and it's cheap. So this is kind of the general idea with ZK proofs at large, but the premise is that you prove the kind of origin of the data once. So you're saying, right, this data was here at this time, and you generate a proof for that, right? And that's quite computationally expensive. That's why we have the prover network, but you can query it as much as you want, right? And that is much cheaper, right? So I think the general idea of ZK proofs is like prove once, verify many times, right? So it's kind of expensive to generate the proof, but then you can verify it quickly and cheaply, right? So that's the same here doing the SQL queries. So as a developer, to give you a bit more detail, when you register the database, you kind of notify the Lagrange network that you want to index a specific contract, and you say which it says here you directly indicate the layout. So you basically specify which data that you want to index in a contract, and like how you want that to be put into the database, and then the network will start pulling that data out every block. Now, in practice, right, so in theory, at the moment on the docs, it says you have to kind of fill in a form to get your contract to start being indexed. In practice, if you're entering the hackathon, I'm in the Telegram chat, right? So you can come in there if you want to get a specific contract indexed. you can chat to me there, and we can kind of fast track you, right? So I'm not sure exactly what the status of the forum is, but if you're doing this hackathon, we'll sort you out, right? So the next part then, so once you've indexed all your data from the smart contract, you query, right? So you send a query to the kind of Lagrange contract. Now, what you do is you give the parameters, which is the SQL statement. So what kind of SQL ops you want to do, and the variables you're looking for. Here's a kind of example here, which is the LPN is Lagrange prover network, the registry dot request, right? And then it's like saying, here's the stored contract, the contract that you've been indexing, and here's some you know, the data that we're looking for, and like, you know, what period, right? So start block and end block is from which, you know, period, which slice of blocks that you want to check some data for, right? And then when you receive the result, you receive that in a callback, right? And so you get this kind of generic array back, which your contract can then use, right? To, you know, do something with the result, right? So we're going to talk about a couple of use cases in a minute, but it's wrapped in a Groth 16 proof as well, so you can verify, right, that it's valid data as well, right? So that's kind of it's pretty simple to understand conceptually. It's slightly more complicated to get cracking on, but that's why you're doing the hackathon, right? Is to learn all this stuff. So this is the kind of, the slide was supposed to be hidden. This is the big diagram of how everything works together, which we'll take a quick look at. And it also sort of it hints at this idea of doing cross-chain querying. But basically, what you can see here is you have a smart contract, you index it, you send a query, and then there's the Lagrange registry smart contract that interacts with the ZK coprocessor, which is these bits of software that kind of run on the ZK prover network. And then there's these bits and pieces going back and forth, right? So that's how it works. And then it's not just like passing in data from any old source, right? The magic is, or the thing that holds it all together is that it's all done using ZK proofs, which you can verify in your smart contract for a reasonable amount of gas, right? So those of you who know about ZK will know there's different kinds of ZK proofs. Some of them verify in a reasonable amount of time and expense on Ethereum, and then some of them don't, right? So that's one of the challenges, is to kind of get them to work together. So I said we'd take a look at a couple of case studies. One of them is this thing called reward pool contracts. So this is just the idea that you know, there's some specific contracts that DeFi protocols use to do these kind of reward programs that you might be familiar with. You might use them, you might have worked with them. So basically what you can do with the Lagrange solution is, what you can do is you can basically use Lagrange to keep track of who owns what percentage of like the pool, or who has staked what asset at each block, and you can put that into a table that you can then query with SQL, right? So what we've seen partners do is query that data to say, you know, how much we want to give out, like a certain amount of rewards per week to everyone who's owned, you know, put liquidity into this pool, or put something into this vault, or stake something over here. But you can think of other use cases you want, right? So the key idea is you track who owns what over time, right? And you can kind of do things based on that. You can give rewards, or you could, you know, give them some other access or something. And right, so I've got one more use case, which is similar idea but with NFT contracts. So you can check who's owned which NFTs at specific times, and see if they're eligible for goodies or memberships, or kick them in or out of a chat group, or whatever you want to do with your NFTs. But the key idea is you can check who owns what at which time, and you know, you make some decision based on that. So hopefully that should give you enough to start thinking about use cases. I will be in the Telegram chat that's to do with the hackathon, and also you can get me on X as well, or Twitter. I'm going to post my names as well. And so we have, right, this is to do with where we are with Lagrange. I'll skip that for now, but you can go and check all this stuff out on the docs. There's a lot of very exciting stuff happening, and we've got an event at DevCon. So if you're interested in that, come and get in touch with us as well. Now, thanks for listening. I'm Blockbeard on Telegram. I'll be in that chat as well, in the Lagrange kind of sub chat, or the alt layer Telegram chat thing for the hackathon, AVSthon, and I'm Blockchain Beard on X Twitter. So you can tweet me or you can message me on Telegram. Also, the Lagrange bounty is $5,000. And so what we are looking for is people to build stuff, new use cases using the ZK co-processor. So that's just that kind of idea of you index the data from a smart contract and then you use the SQL queries to do something with that data, right? And so I would imagine, right, obviously, we want to see stuff which is built and working, but also what we're really looking for is, novel ways to use it, right? So people we've built this technology, but we need people to come in and have a real think about new ways it can be applied. So with that, thank you very much. I think I've gone over slightly. Sorry about that to the team. But if anyone's got any questions, this is where to get me. Thank you very much. I think I'm about to be. I'll say goodbye. Are you going to kick me off? Good.
Hi everyone, this is Michael from Brevis. I think we are very excited to join the AVS hackathon here with AutoLayer and EigenLayer. And in this short 10 minutes, I'm going to just give a quick introduction of what Brevis does, and also walk through the bounties that we are hosting for this particular hackathon. So Brevis is a production-ready ZK coprocessor. Now, the concept of the ZK coprocessor is that if you have a smart contract on a blockchain but want to do some very complex computation, what you can do using ZK coprocessor is to essentially offload that very complex and sometimes data-heavy computation to an off-chain environment. You do the computation in the off-chain environment, but at the same time generate a ZK proof of that particular computation. And then along with that ZK proof, you post the result back to the blockchain so that the smart contract can cheaply verify the very heavy computations result and utilize that computation result directly in the smart contract. So essentially what ZK coprocessor does is it is a scaling solution that allows your smart contract to access more resources. Now, for Brevis does a lot of things, but for this particular hackathon, we want to focus on the ZK data coprocessor aspect. Now, what is the ZK data coprocessor? The ZK data coprocessor is a solution that allows you to enable your smart contracts to access arbitrary historical blockchain data. And that's not only states and storage slots, like some solution does, but we also have full-fledged support for things like events, transactions, account status, and all of that will be available in the Brevis SDK. Now, to use Brevis, you can build a lot of exciting things. Like, the simplest example that I always go back to is you can build something like trading volume-based fee discount on all the DEXs, right? So like, before, if you look at all the DEXs today, you don't actually have any DEXs that are offering differentiated fee tiering based on the trading volume of each of the trader. But if you look at all the centralized exchanges, every single centralized exchanges offers that kind of feature. The reason that this kind of feature is missing in DEXs is because it is very, very hard to actually access these kind of historical data and do computation on top of them. And what Brevis enables you to do is exactly that. And you can access all the historical trade event and do aggregated computation like summing up, doing average, calculating volatility on top of them. Now, from a very high level, using Brevis SDK is quite simple. There are really 3 steps. First, you specify what kind of data you want to read, be that like transactions, like user swap event, user lending event, liquidation, adding liquidity, whatever you want. And also like user state, like who owns what NFT, what is the account age, what is the account nonce, what is this transaction gas cost and everything. And then, after you specify what type of data you want to read, and the second step is to specify what kind of computation you want to run on top of that. Now, the computation process, of course, does not require you to write any ZK circuit. We provide a very easy to use data stream API where you can apply data stream abstractions like map, reduce, filter, group by, zip, sum, and all of these kind of primitives to the collection of data you got in the first step. And then, the result of the computation will be automatically posted back to the blockchain as a callback function to your smart contract. As long as your smart contract implement the callback interface, it will be able to receive the already verified result from the off-chain environment. And then, reuse that data directly in the smart contract. So this is like basically from a high level what Brevis does. And, just to kind of jump into the specific, requirement for this particular bounty program, we are offering a $5,000 bounty. And the task at hand is to really build data-driven dApps with Brevis ZK coprocessor. We have, so the idea is that, as I mentioned, you can build like any kind of ZK coprocessor applications, using Brevis SDK by, learning and learning how to use ZK coprocessor SDK and like to access historical on-chain data, transactions, events, and do computation on top of that. So, what we're looking for in this particular this hackathon is novel ideas and, as much as possible, a complete implementation. Now, using Brevis is pretty straightforward. Like, we provided a lot of examples of public developers building on some existing and the previous hackathons. So to show that the Brevis SDK is really production ready and something you can directly use, right? So these are all provided here. For example, we have partnered with Atrium and also actually EigenLayer and Uniswap Foundation for the Uniswap Hook incubator program, where there is a hackathon that to build like a novel applications and the type of like data-driven DAX features using Brevis and other solutions. And you can look at some of the examples here. And also we recently launched and still in progress. This one is a hackathon with PancakeSwap to enable data-driven features on Pancake v4. And there are 26 submissions, and we have selected 14 finalists. All of these solutions have source code available in the public. You can actually look at those source code to get some inspiration. For example, you can build Uniswap v4 hooks based on traders' historical trading behavior, loyalty and user retention features in DeFi, gaming, and any other features. User gating features based on historical user behavior. You can even build novel solutions for block space trading. Like if you want to build something like a pre-confirmation solution to trigger pre-confirmation slashing using Brevis, you can definitely do that, and so on and so forth. So for this particular hackathon, we want to limit the type of network supported. Like if you want to build on Ethereum mainnet, perfectly fine. If you want to also build on BS, if you want to build things based on BSC mainnet data source, that's also perfectly fine. So we have both environment available for you to build for this particular hackathon. And so we also attached a bunch of useful information. So I think the most helpful information to look at is actually our SDK documentation is pretty full-fledged. So if you look at the introduction section, you get an idea of what Brevis actually does. And then, the most helpful thing I would say is to go through the application workflow and also the tutorial. After that, you get a rough idea in terms of like how Brevis application actually works. And then, you have all the SDK references. But don't worry, like, I think if you encounter any issue or questions, we're always here to help. And we're very active in Discord and also Telegram. If you just like ask any question on Telegram, we can reply that in a couple hours at the at most. And just to show a bunch of like partners already launching production ready feature with Brevis, like Quanta, which is one of the biggest perpetual swap aggregator on AVSthon, recently launched their trader loyalty program enabled by Brevis. It's actively being used by a lot of professional traders. And also Jojo launched like a decentralized funding rate update feature on mainnet to make the funding rate update entirely trust-free. And there are so many others like that are also in our blog post that can give you some inspiration as well. So with that, again, like we listed all the information in the bounty kind of info and the bulletin here. But if you have any question, don't hesitate to ask. We're very much happy to help. Yeah, with that, I will give the stage back to AVSlayer team.
Hello, everyone. Let's start. This is Jia Quan, the co-dev in Automata. Welcome to today's Automata Boundary TE track as part of the AVSthon. And we encourage all developers in AVSthon can participate this TE journey. And later I will share some details about this boundary. And at first, about Automata, we are building a modular attestation layer that establishes trust in computing machines by verifying their authority on chain. And the TE coprocessors are one of the biggest unlock for open invocation in EigenLayer AVS landscapes. And currently, our multiple AVS on EigenLayer support both score and linear networks. And there are around 70 operators are joining our AVS. And we are also extending our impact to other rollups networks. Besides working with the Workcoin Foundation, we are trying to use the TE-compatible GPUs, the NVIDIA H100, to extend the influence of the TE technology stacks. And in this AVSthon, Automata released a 60K ATA boundary. Here is the task that we are looking for to develop AVS that use either the Automata SGS SDK or the Automata DCAP v4 libraries. Later, I will share more details about these two tools and how they work. The Automata SGS SDK is a Rust indentation that allows developers to build application that run within Intel SGS enclave, and it is supported by the Cargo, and it is focused on being user-friendly, fast and efficient tools. And we build such SDK to accommodate a broad user base, including the industry projects. Developers who are interested to build with the TEs, but might not have much more knowledge or don't know how to start, and who often have conflicting requirements and domain knowledge. So within this SGS SDK, it will simplify your TE journey, and the developers can focus on what they need to do in the applications. And natively, by leveraging this SGS SDK, you will have a entire TE environment to be executed inside your applications. And for the second one, the DCAP v4 libraries, it provides a unified interface to verify the Intel SGS or TDS attestations on chain, which means if you are very familiar with the TE stacks, especially focusing on the Intel TDS or some other TE terminology, you can still use this v4 libraries to perform on-chain attestation with smoothly. And part of his design is the on-chain PCS, a decentralized repository to manage, store, and reuse the Intel decap collaterals. And it also supports two verification modes for the Intel decap attestation, the native rate and the proof aggregation rate, by using the RISC-0 to speed up and to optimize the gas cost on-chain. And it would directly use the code verification on-chain for some economic security. And here is the guidelines that we are looking for these AVSthons. For your AVS, it should use the TEs in a novel way, which means it is meaningful to integrate with TE inside your application to enhance your whole AVS secure level or the secure guarantee that you give your users. Instead of focusing on the TE to the AVS, we want to see a need possible requirement to and apply it. So we will consider the ideas that how you put the TE inside your AVS and how it works. And in your project, you should have a clear structure of the proposal on how the TE works in AVS as a POC solution. And last but not least, it should benefit the ecosystem at large, and the key components should be open source. And then everyone in AVS or EigenLayer can share all the technology that you have for these AVSthons. And here are some useful links and resources that you can find on how to use the TE, especially focusing on the Automata SGS SDK and the decap v4 library that I mentioned before. All these repos are open source, and feel free to try it out and drop any questions in either Discord or Telegram if you meet during your development. And we are good to answer your questions and get to help you to figure out what how to integrate the TE into your applications. Yeah, I think so much for the sharing. Any questions? If not, then we will see how you can build the AVS in the TE to see how the things will work. Yeah, thank you for everyone.
So thank you, Brevis, Lagrange, and Automata for the presentation, the bounties. So gentle reminder, we have the main prize pool, the reward pool, which is provided by EigenLayer and AuthLayer in USDC and all tokens. That's about the rewards that goes across all the participants, including some of the top 100 ones. And then you have these bounty pools provided by different tracks, providers. So Automata, Brevis, and Lagrange. Again, finally, before we go off, I would like to leave you with the two QR codes that you can take a look at, which is the QR codes for the two links. So hope you can see it. So this is the first, again, reminder, the first QR code on the left is the QR code that will take you to the hackers tutorial, the guidelines, and the rules of the game. The second one is the devfolio page, which is the portal that we're going to use throughout the hackathon for you to submit projects, for us to judge those projects, and so on. So if you want to register, and if you haven't registered yet, please go to the devfolio registration page and then go through the hacker's guide to understand what we're expecting, what sort of projects to build. It also has a link, as I mentioned earlier. It has a link that presents you the wish list of AVSs that you would like to see and build. So thank you again for coming in. This was the first session, the kickoff session. We have a few things planned over the next few weeks with more speakers, and we'll do some hackathon workshops and some office hours where you would come and ask questions to us regarding Wizard, the tool that you would be using throughout the hackathon, but also to EigenLayer team if you have any AVS related questions. So thank you again for joining in. We'll see you soon online. Thank you very much.